Hi, all remote learners. So today we're going to be reading in our textbook, which is the StemScopedia. It's the yellow book. You were going to be starting on page 7, and we're going to read all the way to page 10. Again, it's the StemScopedia, the yellow book. We're going to start on page 7 and end to page 10. So you can follow along with me right here or follow along with me with your textbook. All right, let's begin. Everything around us is made out of tiny bits of matter. These particles may combine in different ways to produce new materials. Sometimes we need to separate the parts of a material. If we know how the small bits are combined, we can often figure out how to separate them. In these lessons, we will focus on 3 different types of materials. Some examples include pure water, seawater, and rocky soil. How are these materials similar? How are they different? Let's continue on by moving it down. Each of these materials is formed from different ingredients. We may separate these particles in different ways. How would you separate the parts that make up each material? How you plan to separate the parts will tell you more about the types of material. So we can see at this picture where we have the seawater and the rocky soil. Seawater, rocky soil. So how is seawater different from pure water? How is it different from rocky soil? So pure water and seawater, how are they different? And then how is it different from rocky soil that we can see in this picture here? Okay, let's continue on where it says, what is a mixture? So first we must learn the difference between mixtures and compounds. Sometimes particles combine to form a completely new kind of material. The particles become connected in new ways that are difficult to undo. In these cases, we say a compound has formed. Other times, particles do not form a new material when they combine. The connection between the particles are not difficult to undo. In these cases, we say a mixture has formed. Making a mixture does not create a new material. This is true even when the mixture looks very different from the particles combined to make it. Compared to compounds, mixtures can be unmixed pretty easily. Later in this lesson, you will learn how you decide to unmix something reveals whether something is true, whether it is a true mixture. So let's go back up and see that picture that we had of the Rocky Road. So that ice cream right here, which is the Rocky Road. So Rocky Road ice cream is a mixture. Combining marshmallow, almonds, and chocolate ice cream does not create a new kind of material. So again, what we've talked about in our textbook about creating a new type of material. We do have these different things that are combined in the ice cream itself to make that Rocky Road ice cream, but it does not make a new material. So let's read what it says, try now. You will need some marbles, a shoebox, and something that can cut holes in the shoebox. So we're not going to be doing this. I just want to read to y'all what it is. Again, we're not doing this because, we need to be able to understand the textbook and the information before we begin about mixtures. So I'm going to continue reading, but again, we're not doing this one. So we'll make holes, little holes bigger than the marbles. Cut several squares out of the lid. The squares should be as wide as the marbles. The box of the bottom of the box, marbles, and the squares should look like this. So we have the picture here, and it shows you what it should look like. So you're going to put the marbles and the squares into the shoebox, creating a mixture. Then shake the box back and forth. How will this help you to separate the marbles from the squares? What properties of the two shapes allow you to separate them? Imagine adding a cup of cooking oil to the cup of water in a bottle. Let's continue on so I can scroll down. So you screw the cap onto the bottle and shake the bottle. Now the liquid looks cloudy. Is it a mixture? When you let the bottle sit still for 10 minutes, the oil rises to the top. Now you see a layer of water at the bottom and a layer of oil at the top. But is this a mixture? So let's continue on reading what a solution is. What is a solution? We saw the materials can be either compounds or mixtures. However, scientists identified two different kinds of mixtures. The mixture of marbles and squares is the try this activity in one kind of mixture. In this kind of mixture, you can still see the bits of the materials that make up the mixture. The bits haven't changed. They still look the same as they did at the beginning before you shook them up. So we can see the ocean here in this picture. So the ocean is a solution of salt dissolved in water. So again, ocean is a solution of salt dissolved in water. So let's continue on. What do you think? Picture what happens when you mix salt with water. What about mixing sugar with water? The salt and sugar seems to disappear into the water. How is that possible? Things don't just disappear. The answer is that salt water and sugar water are examples of a different type of mixture called solutions. In a solution, the parts are mixed all the way down to the smallest particles. These particles are much too small to see, but they are still there. They haven't changed. Compared to the other kind of mixture, the parts in a solution are much more evenly and randomly mixed. When materials like salt and sugar disappear into a liquid, we say that they are dissolved. Later, we will see how dissolved materials can be made to reappear. Solutions are separated in a different way from other materials. Remember, mixtures and solutions are not separate things. A solution is one kind of mixture. All solutions are mixtures, but not all mixtures are solutions. So let's continue on. So let's look out. So let's see. When ice melts, it changes to water. Sugar and salt can also melt if they get very hot. When they do, they become clear like water. When sugar and salt dissolve, they form clear solutions. Does this mean that melting is the same as dissolving? Not at all. Melting is what is called a change of state. Solid, liquid, and gas are three different states of matter. And we've learned about that when we did matter last week. Melting is a change from a solid state to a liquid state. Melting does not form a solution because one material is there. Salt water and sugar water are mixtures because two materials are being mixed. Just because everything ends up as a liquid does not mean that anything has melted. How can materials in a mixture or solution be separated? Some mixtures can be separated by physical processes. A physical process uses the physical properties of matter to separate a mixture. For example, you can separate a mixture of sand and rocks with a strainer. The sand will fall through the holes and the rocks will stay in the strainer. So let's look out. A strainer wouldn't separate a mixture of sawdust and sand because sawdust particles and sand particles are about the same size. To separate this mixture, you could dump it into a bucket of water. The sand would sink and the sawdust would float. Now think about sand mixed in water. How would you mix those items? Perhaps you could use a filter. A filter can separate a mixture of small bits like sand and liquid. The paper in a filter has very small holes that let water pass through, but not solid particles like sand. How about metal items? There are tools that can help us excuse me, help us separate those items too. A magnet can help us separate some types of mixtures. Magnets attract anything made of iron. You could use a magnet to separate pens and toothpicks. And we did learn about magnets and see what they meant when it comes to if something is magnetic or not when we learned about it in our matter week. What happens when water or a water solution is exposed to air? A water solution is water with something dissolved in it. Water molecules leave the liquid and move into the air as a gas. This process is called evaporation. As water evaporates, the dissolved material is left behind. Solutions are usually separated by evaporation. Warming the liquid speeds up the evaporation process. If a solution of salt water or sugar water are allowed to completely evaporate, the salt or sugar would be visible at the bottom of the container. The salt and sugar particles would look much as they did before they were dissolved. So all the processes mentioned above are physical processes. The other kinds of processes is a chemical process. In a chemical process, a new material is formed. For example, hydrogen and oxygen are two pure gases that combine to form water. The water is not a mixture. It is a new material that is different from the beginning ingredients. The water can be separated into hydrogen and oxygen, but not by any physical process. Looking to the future, drinking the ocean, water, water everywhere, nor any drop to drink. This is a line from a famous poem about sailors on a ship in the middle of the ocean who ran out of water to drink. The sailors are surrounded by water, but they can't drink it because ocean water is salt water. So this is what we read when it comes to page 7 through 10. You'll have another video to watch, and it's going to be going over the information on mixtures, and then we'll be doing a quick little lab over it. So make sure you're doing your lab and watching the videos over mixture. See you later, guys. Bye.